All right, so in this lecture, we're going to talk about Newman projections. Newman projections are yet another molecular representation, kind of like bond line structures. One of the things that we're going to be using Newman projections for is to talk about rotational, what are called conformations of a molecule, right? So we know about like constitutional isomers are different connectivity of atoms. But in a given molecule, they can rotate about their single bonds. So each time a bond rotates, that would be considered a different conformation, okay? Some of them we're gonna see are more stable than other ones. Other ones are more high energy. That's what we're gonna be exploring today, is this idea of rotational conformations. Before we can get to that, we need to know how to draw these Newman projections, okay? So let's take a look at what a Newman projection is real quick. So first of all, we just have ethane. We were going to do the bond line structure of ethane. That's just that little dash there, right? These carbons are implied, and then each one has 3 hydrogens sticking off of it. Usually in a bond line structure, we just have those hydrogens be implied, right? We're going to see that they're going to be more explicitly drawn here. They're more consequential. We could draw ethane in a similar bond line structure where we explicitly draw those hydrogens, and we use this wedge and dash notation. Okay, so just to remind everybody what that is, right? These wedges, these like bold triangles, are bonds that are pointed out of the page, so sort of shooting out behind you, right? Whereas the dashes are meant to be pointing into the page. Okay, so these are a way that you can sort of draw a 3D structure using, you know, a 2D pencil and paper sort of thing. They're trying to convey 3D information. Remember, this carbon right here is sp3 hybridized, which means that all those atoms it's bound to are arranged in a trigonal plane, a tetrahedral sort of way, right? So we have to consider that geometry when we're doing our bond line structures, or when we're doing our wedges and dash structures. And we're going to see that it comes into play when we're doing, hi Kitty, when we're doing our Newman projections. Okay, so let me just show you real quick what a Newman projection is. That would be this one over here. And what you can sort of see is it's as if I took my wedge and dash structure that shows where those hydrogens are, and then I kind of like rotate it. If you have a model kit, this is a great time to bust out that model kit because you'll be able to see this a lot more clearly. So I rotate that, I get this kind of like sawhorse conformation, and then the Newman projection is all about looking down sort of this bond here, okay? So let's pick this Newman projection apart a little bit. So again, here's my ethane, and the whole idea is that I'm looking down this bond, okay? So in my Newman projection here, of course, I have my 3 hydrogens in red. Those are my 3 hydrogens in red, and then my color-coded hydrogens in blue. So let's see if we can't pick apart what's going on in this Newman structure here. So those 3 hydrogens are bound, the red hydrogens are bound to this front carbon, okay? That's represented by the very middle of this like Mercedes-Benz symbol that you got going on here. All right, that very center, that intersection is meant to represent this front carbon. Okay, so this is the... And if you notice sort of the way that we're looking at it here, we're looking at it in such a way that the front carbon sits directly in front of that back carbon, right? So you can't really see that back carbon back there because you have this front one in front of it. So this back carbon, let's use a different one. This back carbon here is what's represented by this circle. Okay. The front carbon is that intersection of that Mercedes-Benz symbol. The back carbon is that circle. It's drawn that way specifically so that you can see it, right? I mean, it's not like it's big and sticking out back there. It's just drawn that way so that you can see what's what. And then importantly, you want to see how these hydrogens are arranged. So again, I have my front carbon in the middle here. Whoops, let's do this. front carbon in the middle here, just like in this structure where it's bound to 1, 2, 3 hydrogens, you can see that that front carbon has 1, 2, 3 bonds. Okay, likewise, we have the back carbon here. It's bound to my blue hydrogens, 1, 2, 3. I guess I could have switched the colors. That would have made more sense. Anyway, I have my back carbon here, and notice how it is bound to these 3 hydrogens. They stick out just from that circle, that back carbon circle. Okay, and now you can hopefully maybe see how we're going to be using this to talk about single bond rotation. Bonds can rotate, so these hydrogens can rotate relative to one another. I can kind of turn this front wheel right here so that that red hydrogen gets closer to that blue hydrogen. Let's just again kind of break out how we would go about drawing this. Okay, that's the big thing, big takeaway from this video. I'm actually going to make it separate from talking about the rotational conformations, just so you guys can replay it and make sure you know how to draw the Newman structures. It's super duper important. Okay, so what I'm going to do is, and I'm really kind of focusing on this structure here, because that's what we're going to need to do. We're going to need to convert our bond line structures with these wedges and dashes into our Newman structures. That's the hard part. So I am again kind of looking down this bond here, okay? So again, remember the wedges, they're pointed out at you, the dashes are into the page, and these straight lines, these are what are called like in the plane of the page, okay? So when I'm gonna draw my Newman projection, I'm gonna start out with that Mercedes symbol business, okay? And then I'm going to draw in that back carbon. As it's drawn in this particular way, we see that there's what's called a staggered conformation, where the red hydrogen on the front carbon is sitting exact opposite of the blue hydrogen on the back carbon, meaning one's pointed one way, the other's pointed the other way. So if I'm going to represent that, this would be my blue hydrogen here, my red hydrogen here. I'm even going to color code these a little bit more specifically so we can tell who's who, right? So that's all I've drawn thus far. Now I'm going to worry about my wedges and dashes, okay? And remember, wedge pointing at you, dash into the board. So then where is this hydrogen going to go? Is it over here or over here? That's the question, right? It's on the front carbon, so it's got to be on one of these 2 bonds, but on which side? So remember, so if you have a model kit, this is great. But what you kind of sort of do is you're going to pick up your page, and remember, you're looking at it this way. So my green hydrogen will now be pointed, which is in my bond line structure pointed out at me, means that it's going to be sitting on the right. Whereas the other hydrogen in the back here is going to be on the left, the one that's pointing into the page. All right, so now I got to draw my other bonds for my back carbon. Okay. I have this hydrogen right here is pointed out at me. So again, when I take it and rotate it, that means it's going to be sitting on the right. And then my last hydrogen is pointed into the page. So when I pick this thing up and rotate it, it's going to be sitting on the left. Okay. So that's how we go about converting from this bond line structure with the dashes and wedges to the actual Newman projection. Oops. All right, so obviously it's all well and good and kind of easy when everything is just hydrogens, but what about when you have multiple things to keep track of? So this is why I kind of was color coding last time. But let's just see. So first of all, I mean, this is a good example here because I've chosen all different substituents to be on my molecule. And so you can see how that translates to our Newman structure, okay? Again, the ones that are pointing out at me, the bromine and the iodine, those end up sitting on the right. The ones that are pointing into the page, In this case, they're both hydrogens. Those are going to be sitting on the left when I take my molecule and turn it. Okay, so now let's do some more of just common bond line structures here. All right, so this is now, we should be able to name this, right? 1, 2, 3, 4, 5. So this is going to be pentane. So how do I draw a Newman projection of something like pentane? Notice that I don't have all my hydrogens explicitly drawn here, right? Normal bond line structure, you won't. So I just have to know that here is both a hydrogen pointing into the board and a hydrogen sticking out of the board on this carbon, and same thing here, right? So those are just sort of implied in our bond line structure. I'll draw them in explicitly for now. And then what are the other groups? So unlike before, everything was hydrogen. Well, now down here, this one would be a CH3 or a methyl group. So you'll also maybe see this abbreviated ME. I like to do the CHs, but nonetheless. And then attached to my third carbon here is 1, 2 carbons, so a CH3, CH2 group. Or you can also see this represented as ET, an ethyl group. Okay? So now I'm going to draw my Newman projection for this particular molecule. I'm going to draw it like sort of exactly as written, right? So now my bonds that are in the page on my front carbon, it actually points down. So I'm going to start out with this upside down Mercedes symbol. All right, that's my front carbon. And pointing down is going to be that methyl group. Pointing out of the page, I have one hydrogen, and then into the page, I have that other hydrogen. Okay, just so we can keep track of who's who here. Okay, so now I'm going to draw in the back carbon here. And again, this little wheel represents this carbon. Then I have the bonds just coming off of that circle, right? Notice how these lines don't extend all the way to the center. They're just coming off of that back carbon. Pointed up, I have that ethyl group, CH2, CH3. And then on either side, I have my 2 hydrogens. Okay, so this is a good time to take a second and pause and see if you can't get the Newman projection for this particular molecule here. Also a good idea to go ahead and name it. We have 2,3 dimethyl pentane. Okay. And again, like before, looking down this, my front carbon here, I have the upside down Mercedes symbol because this is now pointing down instead of up like in the previous example, right? So here, if you look at the top, my bonds that are in the plane of the page are pointed up. Here, the bonds that are in the plane of the page are pointed down, the first bond. So that means I'm going to start with the upside down Mercedes symbol. And now what's going to go where? So I have a methyl group here, but now I also have a methyl group here. This is still my ethyl group. And then down here will also be a methyl group on that back carbon. Okay, so now I got to make sure to put these in their proper position. Notice even though I have this explicitly drawn methyl group on carbon 2, there's also implicitly a hydrogen. Same thing here. Although I have an explicitly drawn methyl group on carbon 3, there's an implicit hydrogen there as well. Okay, so on my front carbon here, pointed down is a methyl group. Now, of course, the hard part is where is this methyl group going to go? On this carbon or this carbon? So again, pointed out at you means that when you're going to rotate it, it's going to be sitting on the right. So another methyl group there. That means the hydrogen's there. drawing the back carbon. Here, pointed up will be that ethyl group, CH2CH3, right? Pointed up from where I'm looking. And now the hard parts are which side's which. Where's this methyl group right here? Ooh, come on. This methyl group right here gonna go? Well, it's pointed into the board, so when I rotate, it's gonna be sitting on the left. Okay, so that's just how we go about drawing our Newman projections. In the next lecture, we'll see like what they're used for, basically how they're used to talk about the different rotational states of molecules. Okay, so last thing I want to do is just give you sort of a taste of what the Newman projections are really used for. Again, it's all about displaying different rotational conformations of a molecule. So what the heck does that mean, right? Or how are we going to use this Newman projection? Okay, so this is just the same example, last example from the previous slide. But what I'm going to do is I'm going to play with this Newman structure a little bit in the sense that I'm going to rotate about this single bond, right? Single bonds can be rotated about, and that's exactly what I'm doing. I'm specifically going to rotate that front carbon. So everything in the back here is going to stay the same position. But that front carbon is going to be rotated. On my Newman projection, what that's going to look like is I'm going to, in this case, I'm going to rotate 120 degrees clockwise. Could have gone counterclockwise, could have gone 60 degrees, could have gone 47 degrees. Doesn't really matter, right? Whole point is you can display these sorts of things with a Newman projection. That's what it's really used for. So that's what I'm trying to do here is just demonstrate that. So here I'm going to just take that front carbon and rotate it 120 degrees. And what that would look like are all those groups are going to switch places in this sort of clockwise fashion. And now I'm going to redraw my Newman structure. I'm actually going to start with the back just because everything there stayed the same. Makes that easy. But now I'm going to have to fill in my front carbon here. And I'm going to follow where everything goes. So the methyl group that was at the bottom is now going to be located over on the left here. The hydrogen is now going to be located on the right. And this methyl group that was on the right is now pointing down. Okay, so that's all I've really done here is taken this Newman structure and I've shown a bond rotation of 120 degrees on that front carbon and now displayed a new rotational conformation. One good thing to practice is not just going from bond line to Newman, but also from Newman to bond line here. So let's just finish this off by going back to a bond line structure. Well, again, this half of the molecule didn't change. So that's where I'm going to start out is just by redrawing that. Okay. But what happened to this front carbon? So everything about it has rotated, right? So let's just make sure that we can read our Newman projection and figure out what that should look like in terms of our wedges and dashes. So pointed straight down in the plane of this ethyl group, or yeah, in the straight line there, is a methyl group. But now I have another methyl group, so this was my blue one. Now I have another methyl group, the one in green, and where is that going to go? So it's currently sitting on the left. So if I take this Newman projection and I turn it, all of a sudden, this methyl group is going to be pointed into the page, right? It was on the left, now it's going to be pointed into the page. Okay? And so you can see that now we have wedges and dashes. Again, these are two different rotational conformations. And we have two different representations of these different rotational conformations. We have our bond line structures, as well as these new things, these Newman projections, which again, hopefully you can see why they're really good at displaying these rotational conformations. All right, and so now we're going to take these Newman structures and start using them, but make sure we can draw them first.